Okay, guys, so let's journey through a paper. I'm starting with paper 2 as well for physical sciences, because I know it's always a weekend between paper 1 and paper 2, and then people start, fidgeting. So let's get paper 2 sorted, and then we move to paper 1. Now, in the paper I sent you, I know most of us also don't do multiple choice by ourselves. We just run through question 2, and then in the exam you start seeing flames. So it's important for us to walk through. May I quickly check how many of you were able to go through the paper? Just quickly check. If you were not able to go through, I need to know as well. All right, I see a lot of people. Great. Guys, you know what this tells you? That if you think people are not working, you are the only one not working. If almost everyone went through the paper, and when you think, people are not working at holiday, you'll find that you are the only one not working. Thank you, guys. Let's start sharing options of multiple choice question 1 and number 2. Quickly on this page. Share your answers with me. You are allowed to let's discuss, Guys, I want the classes to take a new turn. Let's discuss. Yes, Mohammed says number 1 is B. Which of the following is an unsaturated hydrocarbon? Unsaturated. So the best thing would be to write, even if you don't want to draw, let's write out the formulas. How many carbons do we have in number 2? 1, 2, 3, 4. Guys, if you don't understand any of the concept, please don't keep quiet. 3 plus 3, 6, plus 2, 8. Question is, do you know how I got these numbers? Do you know how I got them? 1, 2, there are 2 of them, so 2, 3, 4. Now hydrogen 3 plus 3, 6. Here we have 2 hydrogens, which makes it 8. What about C? 1, 2, 3, also C4. 3 plus 3, 6, plus 4, 10. And this one is C4. Okay, so you would notice that, check, even if you don't know what to do and you are able to write this out, your answer cannot be A, it can be B, it can be C, they are all the same. So the correct option here is B. So what is B? Is it an alkane, alkene, or an alkyne? Let's revise. Is it an alkane? Is it an alkene? Is it an alkyne? What would you say? C4H8. A quick way. What is 4 times 2?
4 times 2 is 8. So
you are doubling it. It's a double bond. Very quick. So it's an alkane. So 4 times 2 is 8, which means it's a double. So it's an alkene. What about A? If you double it, that gives you 8. But then what do? You add 2 to it. Once I see that I'm adding 2, then I know it is an alkane. So take note of all of those little things that we are adding as we're running through the question. We'll see how far we can go tonight on this question. It's a full paper. Okay, now 1.2. Consider the following, or the organic compound below. What is the IUPAC name? What is the IUPAC name? Okay, the first thing that catches my eye, this contains 2 oxygen atoms. Look, I want you to be smart. For the fact that it contains 2 oxygen atoms, it can only be a carboxylic acid or an ester. So take note if you didn't know, because this is COOH and this is COO. All others contain 1 oxygen. So it shortens what you do. And then number 2, I'm looking at the number of carbon atoms. It's 4. So wait, already by saying it's either carboxylic or ester, I am cancelling this out. All right? Okay, so it could be either of this. But don't let's run. C4 is what? Bute. Okay, so this looks like a possible option. But what is wrong with with C? Check. Meth is 1. Bute is 4. That gives me 5 carbon atoms. So that is out. Earth is 2. Bute is 4. That gives me 6 carbon atoms. So my only option again is B. We have to be smart in the way we think, and this can only be done if your content is in place. So please, as we revise, like I said, we're not going to run. Wherever we stop is where we stop for today. But I need the content in. So make small notes for yourselves as well. All right, next one. Consider the organic structure below. First thing is to see that. What is that? We're not answering the question yet. But look at this. Not the answer. What is that? When I see that COO, what compound, what organic group is that? Linda, that's an ester. That is an ester. Again, if you notice, go back to this page. I have it there. COO, ester. So those little building blocks will assist. That's an ester. Now, quickly, I see that the examiner is talking about what? Isomers. For those of you that are joining us for the first time on this, there's an acronym we use for isomers, for functional isomers. We said, if I have a function, now English, if I say function, I'm thinking of a party. One of the things that I'm going to bring to that party is a cake. And when I see a cake, even if I just serve you a cake now, you're going to smile. You'll be happy. So you smile, and then you smile again. And what does that tell us? Lovely. Carboxylic acid and esters, aldehyde, and ketones. So, I am looking at this ester with 3 carbon atoms. What is the name of the functional? So the functional isomer of an ester is a what? A carboxylic acid. Automatically. Now, how many carbon atoms do I have? 3. 3 carbon atoms. A carboxylic acid with 3 carbon atoms. My answer is propanoic acid. This paper is looking funny. BBB. Will the next one be B? Oh, somebody's giving me 1.4 is C. Okay. But guys, are we okay with that organic section? It's very, very important. Let's do something. Before we come to 1.4, let's go and answer our organic section. Then we come back to 1.4. So we know we're dealing with organic in this first hour. Anything organic. All right? So far, so good. I'm sure you've learned 1 or 2 things there. How to quickly respond. All right. Let's look at this. So go to your question 2. We will come back to all of those multiple choice. Do me a favor. I know you've answered this paper, so I'm supposed to just tell you answers. But we're revising. I want us to look at A. Before we even answer A, B, C, D, E, I need the homologous series. I'll tell you what I mean. For example, I want to know whether it's an alkane, an alkene, an alkyne, an ester, alcohol, ketones, carboxylic acid. Let's shoot. What is A? Let's go step by step, everybody. Come talk to me. I want us to go step by step. Everybody participating now. Okay, I see answers coming in. Let's have, what is A? It's a ketone. Why is it a ketone? Your ketones would have the functional group in the middle of two carbon atoms. So if I draw that out, it's going to give me something like that. So automatically, thank you everybody. It means we're doing good. That's a ketone. What about B? I think that's very straightforward. That's an alkane, so we won't waste time on that. Okay, talk to me. What about C? If you look at C, it's only carbon and hydrogen, right? So it's also an alkane. Okay, now what about D? Nope. D. Talk to me. Anybody with D? No, D is not a ketone. This is what's going to give D away. Let me see if answers on the right. Yes, Ibrahim. Thank you. That's correct. That's going to give it away. That's an aldehyde. Because that group is called a formyl group. Because it's on carbon number 1. So it makes it aldehyde. So that is the first way to answer chemistry, identification. That's an aldehyde. What about E? We spoke about E just a while ago. It has 2 oxygens. So it could either be an ester or okay, 2 oxygen atoms. And what about F? That's straightforward. That's alcohol. So it's important to be able to identify that. Okay. And if you notice, I think we've answered a few things. Which one is an aldehyde? That is done already. That's D. Write down the letters. Which ones are functional isomers? I think we just came back from that multiple choice. We said aldehyde and what? Ketones. But now we need to count. Let's count the number of carbon atoms. 1, 2, 3, 4, 5. 1, 2, 3. There are 2 here, right? 4, 5. So what do we have? A and D. Guys, if you find yourself struggling with this, just take a day to read this. You'll be fine. A carboxylic acid, that would be E. Why are we saying that? It has 2 oxygen what? Atoms. Are we on the same page? Let me know. So please, if you need to put that note down, oh, carboxylic acid, 2 oxygen atoms. It's either carboxylic acid or an ester. Put such notes down. Those are the things that will count. All right, let's look at this. Write down the general formula of the homologous series to which B belongs. What is B? Alkane. Do you notice I mentioned this in the multiple choice? If it's an alkane, what's our general formula? We did that. CN H2N plus 2. Because it is an alkane. Lovely. For compound C, write down the letter of the molecule that is its structural isomer. Write down the letter of a molecule. Okay, compound C. What is C? Alkane. All right, what do they want? They want a structural isomer. I don't think this one is difficult. It's B. It's an alkane. I'm not even going to check whether it's correct or not. It's just an alkane. These are the two alkanes we've done. Structural isomers, what are they? Organic compound with the same molecular formula, but different what? Structural formula. So they are both alkanes. B. Type of structural isomerism mentioned. All right, let's look at this. What type of isomers are this? There are three types of isomers, right? We have chain, we have position, and structure. No, they are all structural. We have chain, functional, and positional. All right. Definitely, it's not functional. The only functional one, I did it. It's cake. Aldehyde and ketones, carboxylic acid, and esters. Okay, let's see this one. What would this one be? What type of isomers? You know the first thing I'll do. Okay, I know, but I want us to be able to identify. Can we draw? Let's just draw for drawing's sake. 3,3-dimethyl-hexane. 2, 3, 4. That's my hexane, right? Carbon 3. 1, 2, 3. So there's that there. And the rest is all of that. Now, if you compare compound B and C, what would you notice? Here, the longest chain is what? 5, I think. 1, 2, 3, 4, 5. Yes. The longest chain is 5. Now, what am I doing? The longest chain here, remember, the chain has to be continuous, is 5. And the one we have, the longest chain is 6. Are we okay with the 5? So what you would notice the difference is what? Chain length. Since chain length is different, then it becomes what? A chain what? Isomer. Organic compound with the same molecular formula, but different chain length. All right. IUPAC name of compound C. Oh, great. I'm sure you guys did this, right? So what's the name? 2? Are you sure? Are you sure? Come, let's check. What? Give me the names that you have. I don't think you're correct. Guys, come. Share the names, IUPAC names that you have. Mohammed has 244. Okay, Kian 2. Okay, Kian 224. You see, that's what I want us to share. I want us to see the correct naming, because I know there's going to be some difference. Let's see. Where's my mouse? Let me go over the names that you guys are sharing with me. Linda, no. Trimethylpentane, no. 0224 trimethylpentane. Linda, you need to tell me the number. Oh, sorry, I'm only seeing the 2 now. 244. Okay, so we have a 244, we have a 224, Mohammed 244, Kian 224, Bali 223. 223, okay. All right, we have a 224. Talk to me. What do you have, Bali Tavo? Why is it 2,3 though? Okay, the answer is 224. But how did we get to that? Okay, first thing, identifying our longest continuous. So carbon. No matter where you go, whether you want to even go the other way, it's still 5. So I like to do that. put a box around it. Now you would notice, check, this is how you know whether you're correct. How many carbons are not in the box? Three of them. So already 2, 3 is wrong. Now you are going to check, we're going to choose where the side chains are closest to the end. And if you notice, Mohammed, this was where you made your mistake. If I label this as 1, 2, 3, 4, and 5, that was what you did, and you're given 2, 4, 4. 4s are 2 big numbers. How are you, Shamil? Good. 4s are 2 big numbers. I would rather go the other way round. Carbon 1, carbon 2. Do you see that these are closest to the end? And I'll show you something that you can also use. So the answer is what? 2, 2, because the methers are on 2. So it's 2, 2, what? 4. Trimethyl. Now, if you find this in a multiple choice, I want to show you something. Trimethyl pentane. So somebody else is saying what? 2, 4, 4. So you are confused between these two. Add the numbers together. What is 2 plus 2? 4. 4 plus 4? 8. What about this? 2 plus 4?
6.
Plus 4? 10. This number is too big. We choose the one with the smallest. 2 to 4. Are we okay there? Those of you that gave me 2, 4, 4 and 2, 3, please I want us to learn. So we sort this. We don't want to come back to this. We want it sorted once and for all. For compound A, write down the structural formula of its chain isomer. For compound A, look at compound A. Can we draw compound A, please? CH3, CO, CH, CH3. I want us to draw compound A. With organic, if you can draw, you can always win. What's the compound again? CH. Okay. All right, CH3, CO, CH, and CH3. CH3, CO, CH. Okay, let's draw. Because I want to ask a few questions. There are 2 CH3s, right? Am I right? Okay, so how do we put this? There need to be 2 CH3. So I'm going to then do 1 CH3. I can also put it here. But something is wrong. Something is wrong. What is wrong? Something is wrong. Okay, if we have it like this, I want us to see something. Something is fishy here. Can we, hold on, I want to see what is wrong here. Okay, hold on. So we have 2 CH3s, right? Just want to check something. Now, we need to deal with this. Do you notice something is wrong there? So what do we do to this structure? I hope they didn't make a mistake in this. This is looking weird. This is looking weird. This is looking weird. Yes, Little? I used 6 instead of... Did I use 6? What do you mean? Let's see. How many carbon atoms? CH3, CO, CH, CH3, 2. Did I get that formula right? CH3, CO, CH, CH3. We got the formula. We got the carbon, right? So, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, why am I having... Hold on. 1, 2, 3, 4, 5. Okay, wait. Something is wrong. This is C5, H, 1, 2, 3, 4, 5, 6, 7. 3 times 2 is 6, right? 6 plus 1 is 7, plus 3, 10. Okay. I want to just check something. What's going on with my head? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Something is wrong. Oh, maybe. Oh, wait. Okay, I think it's correct now. But the way they wrote it, they didn't write that structure nicely. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but the way they wrote this thing. Oh, okay, I see. It's correct. It's no, something is missing. I'll tell you what is missing. That is missing. Because if I were to write it, that is CH3, right? Next is what? CO, CH2. Hold on. And then C. But they just didn't write this thing nicely. It looks correct like this, but I don't like what they did there. CH, CH3, and CH3. Can I redraw this structure? Just want to do something. I want to check something out. Just want to check something out quickly. So it's CH. Oh, all right. Okay. It's me. It is me. It is me. Did it make sense?
Yes,
Makes sense. It is me. Apologies. It is me. So CH3, CO, CH, and on that carbon there are 2. All right. Okay. What are we supposed to draw? We're supposed to draw a structural what? Isomer. Yeah. Write down the structural, for compound A, write down the structural formula of its chain isomer. Write down the structure. So we need to draw. Structure means draw. When this is structure, what do? We just move things around. But be careful when moving things around. It must still remain a ketone. Don't move that carbonyl group to the first. Once you do that, it becomes what? An aldehyde. I don't know if what I'm saying makes sense. We're trying to change things, right? But don't move this to the edge. Once you move it to the edge, it becomes what? All right, let's see. Because they didn't, but also that could also be an isomer. But let's try to draw. Let's see. What can we do? We can do this. We can do that, right? We can do this. Now we can do this. 1, 2, 3, 4, 5. Would you agree with me that this is a correct answer? They are different in terms of structure. How many carbon atoms do we have? 1, 2, 3, 4, 5. How many hydrogens? 3, 4, 5, 6, 7, 8, 9, 10. Organic form compounds with the same molecular formula, but different what? Structural formula.
So wouldn't the double bond to oxygen move to the next carbon?
No, it doesn't have to move. It doesn't have to move. Here, what if I do this? Let's spend some time on this. What if I move what you just told me? What would this be? It's now an aldehyde, no longer a ketone. And that's a functional, although they are different in structure, but they will have mentioned it as a functional what? Isomer.
Isn't for ketone it must be on the middle carbon?
Yes.
Yeah.
Not necessarily middle, anywhere in the middle.
Oh, okay.
As long as it's not the first or the last. So it could be on carbon 2, carbon 3, carbon 4, carbon. So the way this is, it's a ketone. This is also what? Guys, I want us to name these compounds. I want to remove this one. What is the name? Let's call this compound X and compound Y. Please give me the name of X and Y. And please throw questions in. Let's talk. Yeah, I saw that error there. That's why I was saying, okay, something is wrong, but we fixed it. Yes, guys, I need the names of compound X and compound Y. You can unmute to share what you think it is, because it might be long to type. Anybody done here? What's your X? Let's start from Shamil there. For X. 3. Okay, Mohammed. Okay, Letabo. Do you see that if I have multiple choice, you're all going to choose your own names? Come, let's see. X, Kian says 3,3 dimethyl pro. All right. Okay, wait, Kian, let's take it step by step. Guys, when you name, the first thing I want us to see is draw the longest continuous carbon. So it's deceiving when you look at it. Make sure you draw. Because it's not 3. It's 4. It's not 3. This carbon is connected to this carbon. I can still go up like that. So already we know it's 4. Okay. Now, this compound is... Oh, why did I remove that one? This compound is a ketone. So that carbonyl group must be closest to the end. So this is going to be carbon number 1, carbon number 2, carbon number 3, a carbon number 4. This is what determines the numbering, because this is the owner of this house. We good? Okay, so what would it be? What did you give me?
3 methyl, 2 butanol.
What did you give me?
3 methyl, butanol.
Okay. 3 methyl. All right. You said 2 butanol. Okay, which is the same as 3 methyl butane 2 on. So don't be deceived. Make sure you trace all the carbon atoms the longest, because one of the options that will actually be there will be 3,3 dimethyl. So they want to trick you with that. I hope it makes sense, guys. Are we on the same page with the naming? Do we agree with the name? Do we agree? Come, talk to me. Nzalo, Zolunga, Tando, please, Sanda. I need it to be interactive. What about Y? I think that one is straightforward though. What is Y? It's 5. Pentan? All right, that one is very, very straightforward. Okay, beautiful. Oh, is that all? Never. For compound E and F, compounds E and F react to form an organic molecule. For this reaction, okay, what is E and F? Let's go back. Oh, we said E is a carboxylic acid. We said that. Oh, so what do we have? We have propan 1 ol and ethanoic acid. We know it's going to form what? An ester. Okay. What type of reaction is that? All right, that is esterification. I'm going to extend the question quickly. Esterification. What is the name or formula of the catalyst used?
H2SO4.
Wrong. It's not H2SO4, please. It's concentrated H2SO4. If you don't put the word concentrated, you lose the mark. So we are very specific on that. It is concentrated H2SO4. IUPAC name of the organic product formed. All right, guys, I want you to give me, I'm changing this to 5 marks. I want you to draw, use structures to answer this question. What is E again? So we were given C2, H4, O2 plus propan 1. Please use structural formulas. I want you to draw the structure of the carboxylic acid, structure of the alcohol, structure of the ester, like the entire reaction. The entire reaction. It's 5 marks when you see such a thing. And I think they tested the Gauteng learners on that this June. Yeah, you were tested on something like that, if I remember. Yeah. Mama, why you cry when I said class today? You killed me. I was rolling on the floor. I know we are tired. We're not in the mood yet, but I have to force.
ester must be also name.
Yes, please. Complete. Draw the structure name. Because actually we want the name of the ester. That's what the examiner wanted, but I want us to do the whole thing at once. And I want to set you up for something here. All right, I hope we are done. Okay, can we mark? We good? All right, so carboxylic acid, 2 carbon atoms. Whenever they ask you to draw, put this one close to each other. That's the easiest way to do it. Propan 1-ol, 3 carbons. If you notice what I did, the OH group the functional group are closer to the plus so that I can extract my water. All right. This one, the carboxylic has 2 oxygen atoms, right? So let's take 1 from there. There's a chemistry behind that. No. What type of water is that? There's a chemistry behind this, but for now we don't need to know that chemistry. You would see that's your water molecule. So what do I then have if I have to draw? Okay, it's fine. I don't want it to be conventional. How do you name this? When you want to name, do you remember the acronym we're using here? ACE. Plus, we said alcohol plus carboxylic acid will react with carboxylic acid to form esters and what? Water. So we talk about the milli-meal flour made of ACE. You need water to mix it up. So when I want a name, I must follow that order as well. I must start with the alcohol. The question is, where is the alcohol? So if I want to name this, I am going to split this into 2. Where I have the double bond is the carboxylic side. The other side becomes the alcohol side. So what is this? We start from there because that's where the alcohol came from. So it's A first. So what will it be? Propyl. And then 2 here. Ethanoate. Propyl, ethanoate. Did that make sense to you, everybody? Please talk to me. Let's see if we are on the same page. So you slash that into 2. The double bond tells you the carboxylic side, and the other side gives you the alcohol. Let's do something. I know we are in a bit of a relaxed mode, but let's write a quick test. Sorry, I am so sorry. Because I'm just thinking its chemistry is 50 marks. If we, hey bro, open. What did these kids pay you for you not to want to open? Mohammed, what are you doing to my... I know it's you, your eyes. It's Eastern Cape. Some of you might even have done the paper. Well, no, I don't think you were able to do it. They wrote probably almost at the same time with you guys. And if you did it, great. We'll do it again. Question is, would you be able to see? Because I want you to answer all of this at once. Those of you at home, you can... Oh, it's big enough, right, for those of you here? Those of you at home, you can zoom. 2, 4, 6, 8, 10, 14, 16 plus 1, about 17. Okay. Can I give you 12 minutes? Should be fine. It's organic. It's A, B, C. No, even 10 minutes. But for you to think, 13. Okay, guys, we just mark straight, right? Quickly, as fast as possible. This wasn't part of the plan, but I wanted you to just walk through. The table below shows organic compound molecules A to F. All right, define homologous series. Do you remember your definition? A group of organic compounds with the same what? Functional group. General formula. And each member differs from the next. I know most people don't always write that. By CH2. That's the complete definition. A group of the way you are looking, a group of organic compounds with the same functional group, general formula, and each member differs from the next by what? A CH2. If you don't understand what that CH2 means, let me tell you. If you look at alkane, for example, what's the first alkane? You have methane, CH4. What's the next one? C2, H what? 2 times 2, 4 plus 2, 6. What's the difference? It's 1 carbon and 2 hydrogens. And that's how it is. Even if I go to alkene, all of them are like that. So that's very, very important. It's part of the definition. All right, so mark yourself, give yourself a 0 if you got it wrong. No part mark, remember? 0/2. We want to mark. Write down the letter that represents each of the following. Unsaturated hydrocarbon. It has to be a hydrocarbon. C. Am I right? Will it be C? Yes. 1, 2, 3, 4, 5, 6. So this is C6. H. 3 plus 1, 4. 5, 6, 7. 7 plus 3. 10. Yeah, that's an alkyne. Times 2 minus 2. So if I multiply it by 2, I get 12. If I subtract 2, I get 10. So the correct compound is C. It's an alkyne. A compound with a carbonyl group bonded to 2 saturated carbon atoms. That's actually a ketone, which is E. I don't know if you see what they're trying to say there. A compound with a carbonyl group. What's your carbonyl group? Your carbonyl group is that. Bonded to 2 saturated carbon atoms. So that's a ketone. Compounds that are functional isomers. Which one? We know it's aldehyde and ketones, but let's count. Normally, I'm doing this wrong. This is not the way I approach my questions. You know that, right? This would be what? A haloalkane. Normally, I should do that. That saves me time. Alcohol. What is this? Alkyne. What is this? Aldehyde. What is this? Ketone. Okay, so very important. So I can see what's going on quickly. I know it's a ketone and an aldehyde there. Same number of carbon atoms. Meth is 1, bute is 4. So there are 5 carbon atoms. And 1, 2, 3, 4, 5. So it is what? D and E. 2 marks there. Mark yourself. IUPAC name of compound A. What's the longest chain? 1, 2, 3, 4, 5, 6. Do we agree? Yes. Compound A. 6. I know it's hexane. Remember what I told you? Draw. So I see here that I only have what? A chlorine and what? A methyl. But I need to look at the one that is closest to the terminal, which is numbering from here. Carbon 1, carbon number 2. Carbon 3, carbon number 4. Make sense? But when I label or when I write, I must write alphabetically. Chlorine comes before methyl. So what should that name be? 4 chloro 2 methyl what? Hexane. Please mark. Here's how it's marked. The 4 chloro would get a mark. The 2 methyl will get a mark. If everything is correct, you get the third mark. So the 4 chloro gets a mark. The 2 methyl. Please let me know anywhere you feel you are not following so we can quickly deal with that. What about compound C? Can we draw? What do we have? CH3. We have CH. Then I have what? A CH3 in brackets. Then I have a carbon, and CH3. So if you look at this, there's something fishy there in the middle. How many bonds should I have? 3. So that it's now 4. Okay? Longest chain would be that. The way we drew it, the longest chain would be that. The longest chain would be this. Please give this preference. That's the owner of the house. That is the owner. So this would be carbon number 1, carbon number what? 2, carbon number 3, carbon number 4. So what is that going to be? 4 methyl. What's that? Pent. 2 ine. Please, very, very important. The reason why we have those rules is that we all should have the same name. So if you are getting that wrong, that means one of the rules is not in place. Okay. Are we together? All right. Draw the structural formula of compound B. Did you get it right now, the table? B. Okay. 3,4-dimethyl pentan 2-ol. 3. Always start with the parent. Pent is 5, right? Pentan 2, which means 1, 2, 3, 4, 5. Pentan 2. Yes, talk to me.
Pastor, how are you?
I'm okay.
I'm good. So I wanted to ask for 2.3.1, why is the put that we start numbering from the side of closest to the chlorine?
Okay, for compound A, let's draw it. 1, 2, 3, 4, 5, 6. Okay, there's no need to draw. Let's just explain. Or let me do this. Let me do this. So that. Okay, beautiful. Be smart. I'm telling you. Start drawing. Okay. So here is the rule. Let's go over this. So, okay, we all agree on the parents' chain, right? That one is not the issue. I was expecting that question. This is fine. Now, when it comes to alloalkane, the methyl group does not have preference over the halogen. Neither does the halogen have preference. In fact, alloalkane is not, if you go into deep organic chemistry, alloalkane is not a homologous series on its own. It is still an alkane. So we are going to come here and check which one is the closest. So if you look at this, if I start from here, 1, 2, look at it's number 3. So don't put chlorine over methyl and don't put methyl over what? Chlorine. But if I start from here, it's 1, 2, 3. Meanwhile, if I start from here, it is 1, 2. The rule says choose the one with the smallest. I don't know if we are on the same page. So it's part of the rule. Is that Michelle, right? Are we? Okay. I don't know. Somebody else typed. Let me see. There's a message that I'm seeing here. Let's see. Sisanda. Okay. So why don't we start numbering from the chlorine? Isn't it more important than the side chain? No. It's not more important. Sisanda, are we on the same page?
Yes, sir.
Okay. Now, what if I have this? Don't worry, it's a smart board. Let's do something. What if I have this? What was I planning to do? Okay, yeah. What if I have this? What happens? Because from either side, they are both on carbon number what? 3. And I have to choose one side. Now, since they are both on carbon 3 from either side, I'll then go alphabetical order. Make sense? In alphabetical order, chlorine comes before what? Methyl. So I'll be coming from the chlorine side. I hope that makes sense.
Yes, sir.
So those are very, very important things that we need to. So in this case, there are 3 from both sides. I'll have to use alphabetical order. Okay. Great. Good question. Lovely. I love it. I love it when we explore. Where were we? We're drawing what? 3,4 dimethyl. 3,4. So here now, I have already given that. So this becomes 1, 2, 3, 4. 3,4 dimethyl. Does that make sense? 3, there's a methyl on 3, there's a methyl on 4, and my OH is on carbon number 2. Then you put in your hydrogens. Okay, this is the only reason I don't like organic chemistry, this hydrogen. Other than that, I love it. Okay, please let's learn to draw, and please ask me questions if there is any. Compound D has a positional isomer. Define the term positional isomers. Organic compound, I know your definition, you dumped it on the Monday you wrote. No, let's pick them up again. What is positional isomer? Anybody, definition? Organic compounds, we start with that same definition. Organic compounds, yes, help me, with the same molecular formula, but different, now we go into that word, different what? Position of side chain or functional group. The position of the side chain or the functional group is what gives it a positional what? Isomer. All right, guys, please, you have all those definitions. Please, let's start practicing. If what you did for prelims did not work, change the system. Change the system. Not a day before you start walking up and down your house. Compound D. Can we draw the positional isomer of D? All right, 1, 2, 3, 4. So we have 4 carbons, and then on carbon 2 we have a methyl. So we have the, let's be smart again. Okay, we want to draw the positional of this one. Okay, what do we need to do? We can just move the methyl group, that's all. So if I want to draw the position, please don't move the CHO. Once you move the CHO, you are no longer drawing what? An aldehyde. You are now drawing a functional one. So for me, I'll just move this here. And I'm done. I have already changed the position of the side chain. It was on carbon 3, now it's on carbon number 2. And we're done. And I'm sure we can name, even the name you would see. The first one is what? 3-methyl. The second one is 2-methyl, not 4. 2-methyl. Because this would always, no matter what happens, this will always be your carbon number 1. So for aldehyde, that's why we don't write butan 1-al, because it's always on carbon number 1. Okay. How did you guys do in this question? How did you do? Pretty good. Okay. How did you guys do? Did you do well? Are you satisfied with your performance? Not really. Are you satisfied with your performance? Very, very important. Okay, let's move. This question is not done. 60? No ways. Definitely not good. 65 too low. Okay, we're not done with that. Maybe you can redeem yourself on the next page. Because it has some other... Oh, it's 4 marks. Redeem yourself. If you can get this 4 marks, it would go up. Compound F, which is CXY, is an alkane that undergoes complete combustion with excess oxygen, as shown below. And you must understand it will always produce carbon dioxide and water. Determine the value of P. You just balance it. Okay, you try. And write down the condensed structural formula of compound P. Of compound F. Okay, I'll give you 3 minutes. I think 3 should be fine. Hi, Awande, your hand is up. You just balance it, bro. Why not?
It's 6, right? That H2O oxygen is 6, right? Because 2 oxygens they will be, and it gives you not just right? And then the next 4 they gives you condensed structure from 8 plus 8, 16, 16, 65.
What's your answer for P?
4. I got 5.
What's your math again?
16, left hand side. And you got 6
Can you
plus 2,
6 plus?
2 oxygens.
Not 6 plus 2.
Yeah. And then the same thing.
It's 6 plus 2P.
Yeah. So I'm explaining to you it is maths. Balancing is maths.
Balancing is maths. All right. So, guys, here oxygen is the key to use in balancing here. How many oxygens do we have on the left hand side? 16. And on the right hand side, P times 2 would be what? 2P plus what? And that's the story there. Therefore, P should be equal to what? 5. Write down the condensed structural formula. So if my P is 5, I think we then need to deal with X and Y, right? So CXHY plus 8O2 to give us 5CO2. Already I think I have what X is. X is carbon. How many carbon atoms do we have on the left? 5. So it's C5. And how many hydrogen atoms? 12. They write down the condensed structural form. When they say condensed, what does it mean? This is molecular. So this one is molecular. If I do this, 1, 2, 3, 4, 5. This is structural. But I want what? Condensed. So I'll go branch by branch. CH3, CH2, 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 CH3. This is the condensed one. So let's know the difference between the three. No, just write it like that. You're safer that way. All right, guys, that was not a bad 21 marks question. It's almost half the organic. Organic is 50, and this is 21. All right, let's do this one together, which is boiling point and melting point and all of that. All right, the boiling point of 4 organic compounds are shown. I always first like to see what's similar. Okay, I don't know. But let's see. Oh, look at the molar mass. You see the molar mass? All right. Define the term boiling point.
When the
Wrong.
Only remember
Wrong. Wrong. The temperature. You're dealing with temperature. So don't forget. Please, let's start those definitions. If you have to play a game on those definitions, let's play the game. You get it wrong, you get one slap. Maybe, yeah, we just need to do something, but let's start now. The temperature. No. No. The temperature at which what? I won't be spot on. You're waiting for my definition list. Yeah, no. But did the second one work? I didn't. Which one did I give you?
First one, paper one.
Oh,
Paper
that
one work. Only one you must.
really. Then I forgot this. I forgot maybe.
Yeah.
I said I was going to say. I remember. Vapor pressure equals what? All right, the external, even if you don't write that, but just we mentioned atmospheric what? Pressure. Please, very, very important, those definitions. Okay, quickly. Compound C's boiling point is lower than compound B. Fully explain why. Why is compound C, although they have the same molar mass, what would you say? Compound C is lower than compound B. What could be responsible for this? Huh? Okay, why would you say surface area? Let's explore. Those of you at home also explore. They said compound C has a lower boiling point, although they both have, and you see, if they have the same molar mass, you know what's going to happen? They actually have the same number of carbons, they have the same number of hydrogens.
No, he's right. It's lower, yeah. That makes sense. Your surface area.
Okay, let's draw.
Yeah.
Let's draw B. CH3. Now, CH2. This was what you wanted to do, that I said don't do. Because I don't know these examiners, they might say, no, Elena did that. So just give them what they want. All right? If you write what? Huh? Did they say only? Use, okay. They're not serious. I need to look at that memo and fight. Okay. All right. That is B, right? What about C? If we were to draw C, what would it be? CH3, CH. Now, do you notice that there's a bracket there? Once I see a bracket, I'm talking about a chain. Okay. So I have H there, and I have CH3. Then I have what? CH2. So you would notice that compound B and compound C. Compound B is a straight chain, which gives it what? A wider or larger surface area, while compound C is spherical. But how do we write these answers? We don't want to write stories. So what do we say? Compound B is a what? A straight chain. While what? While C is what? Branched. You are done with your first bullet. Now I'm going to talk about spherical. All right? Or yeah, you can say branched or spherical here, it's fine. Because now we can talk about the energy required. All right? Yeah. So the although they have the same type of intermolecular force, but the branching reduces. Okay, so we can say what? The intermolecular force in the straight chain is what? Stronger than in the spherical. If you want to add, because of the branches, right? What's next? We can talk about the energy required. The energy required to do what? It's not a relationship. We don't break it. To overcome the what? Intermolecular force. No, write IMF. In fact, I want you to be specific. Mention the intermolecular force. What's the intermolecular force? It's what? Stop lying. It's the 3. What's the first one? What's the first one? What do you guys use? London. Dipole. And what? hydrogen bond. The three of them are there, you remember? The energy required to overcome the in what? B is more than required in C. Guys, I want to be honest with you. Whatever principle was tested in your prelims will be tested again in finals. That's why we call it prelims. It prepares you. Every concept that was tested in your prelims is the same concept that will be tested in the finals. So please get back to your papers. Which one did I get wrong? If you can fix them, you've done yourself a good, huge amount of favor. But if you don't fix it and you're just studying anyhow, it's not going to help. Yeah, we started with multiple choice today.
Can you do the KC calculation? I guess I was too lucky.
Okay, no, we'll do it. We'll do it. Okay, so let's identify where we went wrong and let's start fixing them. That's very, very important. Okay, so we're good here. Please, let's just be specific. Identify, you compare, talk about the energy. And that's what we did. We identified, we compared, and then we spoke about the energy. All right. Oof, I'm seeing a 6 marks here, but let's see. Compare A, B, and D. Okay, 3 things. Predict the value of the... Okay, what is A? Let's go back. Oh, I put it there, right? That was smart of me, hey? What do you think about A? A is carboxylic acid. Okay. We need to choose, but let's see something. Let's analyze. A is carboxylic acid. What can you tell me about the carboxylic acid? Let's quickly talk about it. It has what? It has all the forces, right? So it has what? London. It has what? Dipole, dipole. And then what? Stop lying. 2 sides of hydrogen bond. That is actually what's responsible for its higher boiling point. What about B? What can you tell me about B? Alcohol. Oh, but we did, no, oh yeah, we're going to B and D, right? B is alcohol. What does it contain? It contains what? London. It contains what? Dipole, dipole. And what? Okay. 1 side of hydrogen bond. What about D? D is a ketone. What does it contain? London. And what? Do you notice by doing this, we know which one is going to be the strongest already? Makes sense? By doing that already, which one would have the highest boiling point? All right, so carboxylic acid, which would be what? 145 degree. Alcohol, 141. And therefore ketone. I think by doing that you have 3 marks. Fully explain. I kind of explained already. Do you know what I've done? I have done the first one. Identified. Now compare. The 2 sides of hydrogen bond in A is stronger than 1 side of hydrogen bond in B, which is stronger than the dipole-dipole. In D. Can we talk about the energy? The energy required, because I'm not writing that now, please. I'm tired, my hand is spinning me. The energy required to overcome the hydrogen bond in A is more than that of what? B, which is more than that of C. So for identifying, you're already getting that. 3 marks there. Now for telling us about the type of bonds. I don't know why. Okay, maybe for the bonds, you get 1 mark for the total, then the strength, and then the energy required.
So we live in the modern age, so can't you like upload all your videos to an AI and then as you talk it writes for you? It's possible.
But I'll still need to do the video.
Yeah, but you're just talking instead of typing.
No, it's gonna write some things I don't want. just traditional for me. Although it's paining, but it's traditional. Guys, are we okay with this? Make sense? I know most of us don't struggle with the concept here. What we struggle with is how to put the answers. So don't write stories, just write that. Okay, guys, you can write this later if you need, but you're just marking. All right. The vapor pressure of 3 straight-chained alkanes EFG as shown below. Write down the IUPAC name with the highest boiling point. We know the one that has the highest boiling point has the lowest what? Vapor pressure. They are not inversely proportional. Please don't write that word. Okay, so what's our answer? Butane. Beautiful. It's the last one. Butane. Lovely. They're not. Because if it's inversely proportional, then we can calculate. But we cannot, there's no constant. Fully explain the trend in vapor pressure from E to G. What do? Do you notice they are all what? Are they all alkanes? Yeah. Ice again. What do? Identify. That's what it means. So let's identify. What type of intermolecular forces exist here? They are all London. So E, F, G contain what? London what? Forces. I have identified. However, what happens? Do you notice the chain length? All right, it increases. So chain length increases from what? E to G, which increases the what? Surface area. In fact, if you want to show them that you know chemistry, the point of contact of intermolecular forces increases. I don't know if that makes sense. When I say point of contact, when I add another carbon, that's a point of contact. When I add another carbon, another point. So as chain length increases, the point of contact will also increase. So can we conclude? The energy required to overcome the London forces, right? In G is more than F and E. Therefore, vapor pressure of G is smaller. Okay. But I saw the Eastern Cape one. It's a graph, and I'm interested in it. Are we okay with this? Is there any question? Because you are doing the graph for me. Unfortunately, you have to start. Guys, are we okay with this? Like I said, even if we do, I'm hoping we can do organic and maybe rate. And then our next session we continue. I want it solidified. I don't want to, it's not maths. Maths, we can do a full paper, you know. All right. Let's see what they have for us. My Eastern Capers. What is it? Brilliant. Gradient. Never. It thinks gradient. Okay, let's see something here. So we're going to answer it in sections. First 5 marks. This one I won't give you time that much. Apologies for the dirtiness of the paper. Okay, come, read through, try to answer. You are trying to remember. Are we done? I want answers to come from those from home. Guys are chilling too much. Please unmute your mics and give me answers. If you don't want to answer, you come here. If you want to answer, you stay at home. Okay, 3.1. I wonder you said 3.2 is a liquid, but let's see. The vapor pressure against temperature curves are shown for 3 straight chain alkanes. The vapor pressure are measured in millimercury there. All right. The atmospheric pressure is 760. Okay. Define vapor pressure. Pressure exerted by the
Vapor.
on the
Pressure is
pressure exerted by the vapor on the liquid.
in an enclosed system at equilibrium.
Good. In a closed system at equilibrium. Please get those definitions. All right. 3.2. At what phase are the alkanes at room temperature? What is our room temperature? Write down gas, liquid, or solid. Give a reason for your answer. Yes. Huh? What is our room temperature? Room temperature is about 20 degrees to 27, some of them.
That's your gas. Precipitating pressure is not.
Okay, the whole idea of this graph is this. What is our atmospheric pressure? I want you to see the whole idea of this graph. Our atmospheric pressure is this, right? Please check that. You see, the boiling, look at this one, C6H that it goes up there, it will only boil at this point. That's the boiling point. It boils at 60. The C7 that will boil close to what? 100. And this one will take longer to boil. So that point of intersection is because it is the temperature at which the vapor pressure, and these are all vapor pressures, is equal to the atmosphere. So that is our boiling point. So it will boil here, but room temperature is about 20 degrees. So it's not boiling at all. So it is what? Liquid. And one day, correct answer. 3.2 will be liquid. Why? Give a reason for your answer.
I was liquid, but I don't know why. How to explain it.
The temperature is below the. No, the temperature is atmospheric temperature, right? So let's atmospheric temperature. No, not atmospheric, rather. Room temperature. Is below the boiling point. Yep. It's below the boiling point. But once it goes above the boiling point, then it becomes what? A gas. How will the boiling point change if atmospheric pressure decreases? If you understood what I explained earlier on. So if we decrease this line, what do you notice? That point of intersection decreases as well in terms of temperature. So what will happen? It will decrease. Oh, not bad. I thought they were going to ask something vavafumish, but they're just asking simple things. They're disappointing me. But you know why I did it? A lot of us will see a graph and chicken out. Okay, let's look at this. 3.4. Do we still need the graph for 3.4? What can be concluded from the curve regarding the relationship between intermolecular force and vapor? That you don't even need. You don't need the graph. Okay, guys, can you answer the remaining 8 marks? Please write answer like an exam. what you would write. Please. 5 marks, 5 minutes. Write like you would write in an exam. All right, let's answer this. What's your conclusion? Intermolecular forces. Talk to me. The stronger the intermolecular force. Talk to me. Are you sure? Yeah, you are right. The higher the vapor pressure. I was just trying to pull your legs. Because what we're saying is this. Is it going to be high though? If you have a strong intermolecular force, then boiling point will decrease. Yes, because boiling point will decrease because it takes a longer time. Okay, wait. The stronger the intermolecular force, the higher the boiling.
Yeah, the higher the boiling point, the stronger.
What am I saying? Yeah, the higher the boiling point, and then the lower. So the lower the vapor pressure. That's correct. I just mentioned that you don't write inversely proportional. Reason is there is no constant. If there's a constant, then I can be able to calculate it. To say I can calculate the vapor pressure of a compound.
What if we invent a constant?
Well, until you invent it, we will wait for it, and only then can we say it is inversely what? Proportional. Right now, look at the fact that we don't say. Let me show you something even from this graph. This graph are not bent the same way. All right, because if it were inversely proportional, I should be able to find the gradient at this point, and it should be equal to the gradient at that point and equal to. So there's no mathematics there. No ways. All right. Define the term boiling point. All right. We just defined that earlier on, right? Temperature with the vapor pressure is equal to what? External atmospheric pressure. Okay. Yeah. Fully explain the difference in the boiling point. This one we did also. ICE. Can we identify? Compound A has what? One site of hydrogen what? Bond. Compound B, two sites. So what have you done here? You have simply what? Identified. That's the I. Identify. What's the next one? Compare. What do we say? The hydrogen bond. I don't have to mention the two anymore. The hydrogen bond in what? B is what? Stronger than in A. I have simply what? Made my comparison. What's the next one? The energy, right? The energy required to break the relationship. No. To overcome the hydrogen bond in what? B is more than in A. Now you've talked about what? The energy. Now 1 mark for each of them. Oh no, you're actually done because they'll give you 2 marks here. Why 2 marks? They gave 4 marks. Already they told us that the boiling point of B is higher than the boiling point of A. So please, very, very important, identify, compare, talk about the energy. All right, sweet. Let's go on this one. Organic reaction.
You're thinking your acronym more beautifully in the paper.
And you made it through.
Yeah.
You survived. Okay. The flow diagram below shows a number of organic reactions. Reaction 1 is cracking. What is cracking? To break down. When you take something and you crack it, it becomes what? Smaller. All right. So reaction 1 is cracking. It breaks down into 1 and 2. Okay. And then we have reaction 2. What do you notice about this compound? Before we even go and look at the questions, let's see something here. This one is 1, 2, 3. It's saturated. because it's C3H8. So it's a saturated organic what? Compound. Now, when that reacts with oxygen, that's combustion. We did that a while ago. Alkane plus oxygen will give us what? Carbon dioxide and water. Okay? Compound S, then the inorganic compound T. Okay, there's a lot of things going on here. What a guan? What a guan? Huh? Okay, let's try to see what the examiner is all about. So we know that this is combustion. We should expect, I'm expecting CO2 plus what? H2O. But they have compound S and an inorganic compound T. I want to see what's going on there. Inorganic compound T. Okay, let's try to, before we even look at the question, I want to see if we can figure out what's going on. All right. Do you notice this is C3H7Br? Now, we are forming an alcohol. This is dilute, if you remember the acronyms. I'm going to show you the acronyms that we're talking about. So this is an alcohol, but the alcohol will also be what? C3H7OH, because we are substituting. This is a saturated. Alcohols are also what? Saturated. Make sense? All right. Saturated, so it's a substitution reaction. So we have an alcohol then. Okay, let's look at what's happening here. This alcohol, presence of H2SO4 then goes up and we form compound. Okay, let's go look at what they are trying to talk about. I want to see what the whole, but I can get compound R now. I can get compound R. Why? Because compound R reacts with what? HBr. All right. So basically, we are replacing that hydrogen there. So this would be what? C3 H what? Is it 7 or 8? No, stop lying. It's 6. Let me give you something that you should write down. Please write this down. Very important. Under cracking, this is very, very important. An alkane will break down into alkane plus alkene. And the second reaction would be an alkane would break down into an alkene plus an alkene plus hydrogen. So there are two sets of products that we can get. So a long hydrocarbon alkane breaks down into a smaller alkane and alkene. Or alkene, and what? Hydrogen. Once I say hydrogen there, I know I'm talking about two what? Alkanes. If you look at this reaction, I'm only seeing two compounds. So I already know this one is what? An alkane. Therefore, this has to be what? An alkene. And you would see I am maintaining my 3 carbon atoms. That's why this is that. Automatically, what would this be? C6H14. Do you know how I got my C6 now? I just added the 3 carbon atoms here. 1, 2, 3. And the 3 carbon. How did I get these 3 carbon atoms from here?
So the alkene is saturated or unsaturated?
Alkene, unsaturated. Alkenes are double bond. So this is what? So unsaturated to saturated, USA. This is what? An addition reaction. Okay. Then from there, we go, so we start from here. I want us to try to see if we can do this whole thing. So we have that, breaks down into this. This goes addition reaction. We go into substitution. We form that. I want to see what's going on here. Maybe there's an information because I'm seeing sulfuric acid. I'm thinking they are trying to give us what? An esterification reaction there. Yes, it makes sense. It makes sense. I'll tell you why. Yes, water looks to be common to both of them. Makes sense. So if this is alcohol, there's an esterification here, which gives me water, and that water also comes from smart H2O, and this one is going to be what? An ester, while this one is carbon di. Okay, look, without even seeing the question, we're trying to figure out our way.
No, we have to mix a carboxylic acid with the
It's going to, I'm sure it's going to come in the question. All right, it's going to come out. But I just wanted to play around to see, can we might come back and change one or two things, but this is what we have at the moment. Come, let's go. Define the term cracking. Okay, guys, I'm sure you can define. What is cracking? Don't say somebody's high, please. No, we're not talking about that crack. What is cracking? What is missing? The breaking down of what? Large hydrocarbon, large molecule hydrocarbon into, talk to me, I want to hear you. There's something you didn't mention. Into what? Smaller. There's a word I'm looking for here. Yes. Usable or useful. Hey guys, your definition. Units. It's on your wall. You're going to take your wall to the exam. Consider reaction 2. What type of reaction is this? Endo or exo? Can we go back to reaction 2?
Oh, this exothermic.
There is a reaction here with oxygen. So this is what? Combustion. If it's combustion, it has to be exothermic. Beautiful. Use molecular formula. Write down the balanced chemical what? Equation. You were struggling with this one. Okay.
Memorize. Mr. Moyo taught us
How to balance.
yeah, but the formula.
Okay, I'll show you something else. All right, guys, this is how I balance mine. C3H8. C3H8 plus O2. Definitely I'm going to have CO2 plus what? H2O. Look at how I'm going to balance. I'm going to start by, don't even think, just put a 2 there. Don't even think. Now, I'm going to deal with the 3, but I'm going to multiply. See, by putting a 2 there, I'm already telling you that there are 6 carbon atoms. So automatically, 6. Now, I'm also telling you that there are 8, that 2 times 8 is what? 16. There are 16 hydrogen atoms, and I have 2 there. I take that 8, copy and paste. Now, all I need to do is to deal with the oxygen. What is 6 times 2? 12. What is 12 plus 8? 20. Now, I have 20 here, divided by 2, 10. But now, if you look at the numbers, I can still divide them by what? By 2. So what do I have? C3H8 plus and we are done. Noble. So I normally balance it in about 4 or 5 seconds.
So no matter what you put there to
Let's can we play with a few questions? Okay, let's play with a few. All right. C4H10 plus O2 to give us what? CO2. What do I have? Put a 2. 2 times 4. 10, copy and paste. 8 times 2, 16. 16 plus 10, 26. 26 divided by 2, 13. Balanced. So just start with a 2 and walk through. Come, let's try another one. C5H12 plus O2 to give us what? Carbon dioxide and water. Start with a 2. Walk with me. 2 times 5? 10. Already I'm done there. Take this 12 and put it there. Because the 2s have already taken care of the 12s. All right. What is 10 times 2? 20. 20 plus 12 divided by 2, 16. But I need to divide by what? 2. So that will give me a 2. That will give me what? 8. I'll tell you when you divide by 2. You would see now when you divide by 2. When the number here is an odd number, you divide by 2. C5. Okay, C6, H, 6 times 2, 12 plus 2, 14. Okay, you want to shoot quickly here? Shoot quickly, let's see what you get and how long it takes you. Come, Shamil. Why is it taking so long? Let's have calculator. Never. What are you missing?
Yeah, I got it. To make this right.
Yeah, I can tell from your face that. But very straightforward.
You don't need points, maybe, so I can memorize.
You need?
Points.
No, just start with the 2.
I got it too.
Okay, look. 2. 2 times 6? 12. 14. 12 times 2.
Oh, you're really in the 14. That's why I'm saying 14.
Because the idea of me putting the 14 there is simply saying 2 times 14. But I already have that 2 there. So we're just inversing it now. So it's 2, 14, but it's 14, 2 there. Then you multiply 12 times 2, 24. What is 24 plus that? 38. And 38 divided by 2, 19. I told you that this one you don't need to divide by 2 because that 6 is an even. If I give you C7 now, you need to divide. Okay, let's try that. C7, H16. Guys, you should use seconds now, please. 10 seconds. 10 seconds. I'm counting down really 10 seconds. Did you make it? Made it? It's because you guys are used to calculators, that's why. Now it's like you are detoxing from your addictions. Done? Okay, can we start with the 2? What do we have? 14 there. Move the 16 over. What is 14 times 2? 28. What is 28 plus 16? 44. 44 divided by 2. Now you would notice they're all 2's, right? So what do? Divide. That 2 would go. What would this become? 11. What would this become? 7. And what would this become? 8. Let's confirm if it's correct actually. Let's check. How many carbon atoms are here? 7. How many carbon atoms are there? That's fine. How many hydrogen? 16. How many? How many oxygen here? 22. Here, 7 times 2, 14. 14 plus 8. We're good. So that's how we balance quickly there, the crazy physics way. Interesting. 3 seconds, you get 5 marks or 3 marks there. So please don't forget, practice again. All right, practice again. All right, we're done. Oh, where are we? Why did we jump? Oh, yeah. Okay, let's look at this one. In reaction 3, compound R reacts with HBr to form compound U, which is a major product. Reaction 3, write down the type of reaction. We did already. It's an addition what? Reaction. Because we're moving from unsaturated to saturated. So it's an addition reaction. What is the reaction condition of addition? We're actually adding what? Halogen. So it's hydrohalogenation. What's the reaction condition? Never. In fact, there must be no water there. If there's a water, it's going to become alcohol. So here, we can actually say no water. Or we can use, yeah, this one is no water, actually. No water. I gave you all those notes on organic reactions. This. No. The other one that I'm thinking about is trying to remember now. I don't want to give you something. Wait, hydrohalogenation, we can use sunlight or UV light. Yeah. Let me just, is that for halogenation? No, you sure? No, I don't think so. Okay, wait 1 second. I know we have 7 catalysts there, right? Yeah, there are 7 of them. And if you just know those things, it just makes life a bit easy. You don't have your card here? This one here is missing something. Can somebody just confirm that for me? I know platinum is for hydrogenation, then hydrohalogen. Please, somebody just, okay, you have it there. It should be on the group. I'll give you that. It works well like magic. There you don't even stress. You just... Please check on the group. Just check images on the group.
Yeah, halogenation is UV or sunlight.
Halogenation is UV or sunlight, right? What about hydrohalogenation? No water. So I'm correct. No water. All right. Because if there's water, then it forms what? Alcohol. Okay. IUPAC name of U. What is the IUPAC name of U? Do we remember? Look at that. What's the name? C3H7Br.
Bromo something.
Bromo something. C3.
Bromo propane.
Yeah, that's it. But I want to see something though. Oh yeah, it's correct. So I want us to see how we got to this part. We started with what? We said an alkene, right? I want us to confirm this. Now we are adding what? Plus H. What system are we using here? This is Markovnikov's. Okay. Now when we open this up, we are going to have that. Guys, the major thing here, because the examiner said it's a major product. So we have this. This is what we have. I have these two ends open. I need to put H and B. You need to be careful about this one. I need to put H and BR. But where is H going to go? H is going to go to the first carbon. Why? The rich gets richer. So this carbon atom has two hydrogen atoms. This one only has one. So the rich gets richer. The one with more hydrogen will get more hydrogen. So it's important to draw before you name, because you want to confirm, is it going to be on carbon 1 or carbon 2? So what's the name of this thing? 2-bromopropane. Which is going to also affect the type of alcohol you are going to form. But by the way, is this a primary or secondary or tertiary alloalkane? Do you remember? Somebody answer, those of you at home. Let's have a, do you know what this, do you know it? Okay. Somebody talk to me. Secondary. Kian. Is Kian still here? Yeah, Kian was the one that told me what on carbon 1, on carbon 2. It's secondary. Can anybody give me a reason why?
Because halogen, the carbon is the halogen is connected to.
Alright, so we're saying the carbon attached to the halogen is attached to two carbon atoms. And that's the reason why it's secondary. The carbon, so this is the carbon that we focus on. It's called a secondary carbon. The carbon that is attached to the Br is attached to two other what? Carbons. All right. And this forms the major product. What is the minor product? The minor product would be if you put this here and you put this here. And the reason it's called a minor is because it's unstable.
I experienced the night before the paper.
Yeah.
What is the same?
Major and minor. So it's unstable. It will change back to become what? Major. So that one is unstable. So we use the Markovnikov. The rich gets richer and the poor gets what? Poorer. That's very important. All right. Next one. For reaction 4, write down the structural. Okay, let's look at reaction 4 again, everybody. Do you notice from reaction 4, we are now starting from our haloalkane using dilute. Please, it has to be dilute. If it's not dilute, then we are going to go, if we use strong concentrated, we are going to have what? Elimination. I want to draw both of them. Very, very important. So that reacting with what? Sodium hydroxide. Please, I want you to see this. This is of extreme importance. We're starting from here. I wish you can find that note. I want to just share it with those, somewhat like Letabo who just came, so I don't have to do the whole drama again. Yes, please. Because I remember we took a picture. All right. Plus sodium hydroxide. Guys, if I just write sodium hydroxide like this, it's actually wrong. I need to be specific whether it is what? Dilute or concentrated. If you see the summary, I know it's like we're saying so many things, but once you see the summary, it's on one page. Beautiful. If I use dilute, then it will be what? Substitution. And what's going to happen? This guy would take the place of this guy. So what are we going to have? 1, 2, 3. We're going to have OH plus what? NaBr. But then if I have it like this, plus concentrated. Oh, another condition that is needed here is mild what? Heat. Here, I need what? Strong heat. What's going to happen? The difference is in the heat temperature and the concentration. Here, I am going to undergo elimination. So if I'm going to eliminate, I have to eliminate this guy and one hydrogen. The question is, which hydrogen am I going to eliminate? In this case, anyone. Why? They both have the same number, 3 and 3. When we eliminate, we usually say the poor gets what? Poorer. But in this case, this one has 3, this one has. So anyone could go. So let's remove from anywhere. You would notice I've gone back now to my what? Alkene, double bond. So this is called the Zaitsev rule. So Markovnikov for addition, Zaitsev for elimination. But the key is, once I use concentrated, I will be eliminated. Did you send it? Did you find it? And when I use dilute, it will be what? Substitution. Please, this is very key. You will be tested on this again, finals. Let me see the picture that you sent. Maybe it's a fake one. Eh? Yeah, my logo must be. Oh yeah, beautiful. Why did you have that dark thing there?
No, you said, I don't know about you editing.
No. I don't know what that dark thing is for.
No, I don't know what it is.
I don't remember.
That will for me to
Okay.
memorize.
Alright, but you can see that just by memorizing that thing, it works now. You've tested it over and over again. It works. So please, I'll take you over and go through again. For reaction 4, the structural, we're doing this, right? The alcohol formed, we got it right? And what's the type of reaction? Substitution. Because we're moving from what? Saturated to saturated. Okay, case closed. For reaction 5, write down the type of what? Oh, you see, they are specific. Type of elimination. Let me see something. Reaction 5. Well, maybe it's not but yeah. Since they didn't bring in a carboxylic acid. All right, so they want to eliminate. Okay, let's go draw that and eliminate. So probably we shouldn't conclude that it's an ester, because I thought they were going to say probably it reacts with something along the way. All right, now I know where we're going. So we have that alcohol. It's there. Alcohol. What's that alcohol again? We have this, right? Guys, when it comes to organic chemistry, if you can draw, you can see what's going on. Okay, I want to show you something. Elena is not sure. I want you to see the beauty of chemistry. Elena is not sure, but they said it's elimination. All right? And you will see the use of sulfuric acid, the strong acid. If I'm going to eliminate anything here, this guy must go. Are you with me? Okay. Sometimes you can just win your way through. If I remove this guy, I can't remove that guy alone. I have to remove, just like what we did now, Zaitsev. So what would I have? plus what? Do you notice that's the water? And that's elimination. So we eliminate. They said type of elimination. What are we removing? Water. What is that? Come. Beautiful. Dehydration. An IUPAC name of R. 3 carbon atoms. Prop. Okay. But this is propene. Do you know why?
Either way, it's the same.
You cannot have prop 2.
Yeah.
Okay. And guys, that's your organic chemistry there. Easy does it. Case closed. You know. Okay, we're going to answer the Eastern Cape one. Then we know we dealt with organic reactions, organic chemistry today, right? Okay. Because I just wanted to be able to apply what you know. This one is even more straightforward. But for the sake of those that just came in, like later, I want to quickly explain what we usually do, because then it makes more sense to you. All right. So we usually say, we use this, I don't know if you've seen this acronym before. All right. So we say, if you move from a saturated compound to another saturated compound, we say it's a substitution reaction. I used to say I'm single and seriously searching. Okay. And then USA. So if I move from unsaturated to saturated, it gives me an addition reaction. Then the name of my wife is Susan, but I call her Sue Baby. Okay? So if I move from saturated to unsaturated, it is what? Elimination. So that's why you were seeing we're writing sat on. That's what you're looking for. Is it saturated? Is it unsaturated? You're done. So myself and Sue got married, but there's so much chemistry. Instead of wedding, instead of saying Bishop weds Sue, there's so much chemistry between us. We said sets chemistry. And the idea is, once I have a concentrated, strong acid or base, as long as it is concentrated, this will be what? Elimination. And if it's a dilute, strong, okay, I would stick to base because we use bases more, then it's what? Substitution reaction. That's when I wrote those two reactions for you. And if it is elimination, if I need to eliminate, I need what? Strong what? Heat. It means to remove something. But if I am dealing with substitution, then I deal with what? Mild what? Heat. And then that picture, I'm just rewriting what you shared just now. And we have our catalyst, which is a picture that was shared on the group. So you see when we say halogenation, we use what? Platinum. Hydrogenation, we use no water. Excess water is hydration. I don't know what you're smoking. Hydrogenation. When we talk about this is the making of margarine. We use platinum. When it's halogenation, yeah, that is sunlight or ultraviolet rays. When we say hydration, see, of alkenes, it means I'm adding what? Water. So that's where we say excess water. Or we use phosphoric acid, which is H3PO4. Now, when it is halogenation, like the one we did today, here I'll say what? No water. Because if I have water, it becomes alcohol. And then if we look at esterification, then we use concentrated what? Sulfuric what? Acid. Why? This one is a dehydrating what? Agent. So these are your reactions. Then we talk about combustion reaction and cracking. Okay, so if we have cracking like we did earlier on, cracking, we said alkane will become what? A smaller alkane plus an alkene, or an alkene plus an alkene plus what? Hydrogen. And if we talk about a combustion reaction, we talk about an alkane plus oxygen to give us what? Carbon dioxide plus the whole of organic reactions done on one page. Just hydrolysis, just reaction of salt with water. We can squeeze that in here. Hydrolysis is actually reaction with water, and it is a substitution what? Reaction. So everything you need on organic reaction is just right here. So we no longer struggle with it. It used to be a problem, but now it's a walk in the park. Okay, can we quickly try the Eastern Cape one? Just to flex muscles a little bit. And so our next lesson, guys, we'll try to see if we can finish now. We'll do your rates, chemical. Please, if you can find as many chemical, let's pump ourselves in, because there's no time. We'll start with the one you did your prelim, right? Okay. All right, let's see what they are asking us here. How many marks? 16. Let's break it down. How much am I selling? Which way do I have it? I'll have it the day before. Oh no, I'm saying this and it's going to be recorded. No, I don't have it. But I can predict it, you know. I'll predict it well in good time. Okay, let's look at this. Don't look at the questions. Look at that table. C6H12O2. That is either carboxylic acid or an ester. I have butanone or that's an alcohol. Okay, so an alcohol is actually saturated. I didn't say organic compound. I didn't say hydrocarbon, but it is what? A saturated organic what? Compound. Now, look at reaction P. They even helped us. They said on what? Saturated. That is SU. So I know this reaction is what? Elimination. Now, that unsaturated, we added HCl. I can simply tell you that this is going to be saturated because this is your Markov-Nichols rule. Because unsaturated will not go to another unsaturated. It only has one way to go, saturated. So unsaturated to saturated is what? Addition. Do you notice what this is? Hydrohalogenation. What's your condition there? No water. So if you want to practice, do what I'm doing. You will see that you have answered all the questions. You know, just that. Oh, sweet. This one is can I conclude that it's an ester? Because I have an alcohol. So what should reaction 1 be? Esterification. Beautiful. Consider reaction 1. Write down the name of the reaction. Done. Structural formula of the carboxylic acid needed. Okay, can you answer that one for me? I want to see something. I have the alcohol. I have the ester. The carboxylic acid is missing. What will it be? We're finishing now, guys. 10 minutes. Because by a mook, but I'm enjoying myself. I wish I could write metric.
They deciding on an after party, but just for our class. And they're going to come with sheets. I don't know.
Are we done? What's the name of the... It's actually very simple though. Because you can just count.
Yeah.
Your bute is 4. Your ester is 6. So you need 2 carbons. And it has to be a carboxylic what? Acid. So what do we know? Ethanoic, right? Sweet. But the examiner says we should draw the structure, but we need the name first. So what are we looking at? 2 carbon atoms, right? There we go. We're done with that. Consider reaction 2. Name or formula of the inorganic reactant needed. Look at this. It's an alcohol. We are eliminating. Do you know your answer? What do you need? From saturated,
strong acid or base.
but let's stick to the base. Concentrated what? Strong base. So 4.2.1 NaOH. But please, if you write NaOH alone, you'll be marked wrong because they are specific now by saying it's elimination. Concentrated what? Sodium hydroxide, or you can say potassium hydroxide. Those are the 2 common ones. IUPAC name of the unsaturated formed. Let's look at it's butanol, right? Let's draw butanol. Butan 1-ol. Okay, if I draw it this way. Okay, let's eliminate. What are we going to eliminate? Check here. I'm going to remove what? The OH. But I need to remove a hydrogen. The question is, which hydrogen am I removing? Look, I can't remove. I've already removed from carbon 1. I can't remove the hydrogen from carbon 1 again. I have to remove from carbon what? 2. So what do I have? 1, 2, 3, 4. Are we correct here? Something is missing. Does that make sense to us? So we remove the OH from carbon 1 and remove hydrogen from another carbon. IUPAC name. What's the name of this compound? But 1-ene. Not butene, because we can have but2. So you have to be specific. But 1 what? In. Case closed there. I don't know if it's making sense. Are we on the same page? All right. 4.3. Let's see. For reaction 3, write down the name of the type of, check, name of the type of addition. So even if you didn't believe my story before, you should believe it now. Because, do you notice, we named reaction 3, addition reaction. And so what type of addition, what are we adding? It's a hydrohalogenation. Okay. Hydrohalogenation. And we know the reaction condition already, right? No water, right? Hydrohalogen. It just makes chemistry a lot easy. Is compound Q primary, secondary, or tertiary haloalkane? Where's compound Q? Oh, it's a major. Okay, can we quickly do that together? We're starting from, so these guys are clever. If you get that one wrong, P, you are going to get Q wrong. But what is our P? What did we say? But 1 in. All right. So if I draw my but 1 in, like that, right? What are we adding? HCl. What are we going to have? And I'll tell you something now. What are we going to have? So we have 1, 2, 3, 4, right? Which ones are open? 1 and 2. I want to tell you something. I once came across such a question. This question is just reminding me. Where would the hydrogen go to? The first one has 2 hydrogens. The second one has what? 1. The rich gets what? Richer. So we add that hydrogen to it. What is this? Secondary. Now, please look at this. An examiner would ask you a question. I'll take you back. I know you didn't notice. How do we convert a primary to a secondary? I don't know if you noticed this. So we started from a primary when we eliminated and added again. So a primary going through elimination and addition changes it from primary to secondary. I once came across a question like that. I just remembered by looking at this. So I hope it makes sense. So how do you convert a primary to secondary? Eliminate, then add. It changes to a secondary. Beautiful. I think we have one last one. And if you have any other question that you want to ask me based on this, then we can. Look at this. Compound Q is heated. Do you notice I was emphasizing these things? Okay, this question is so skewed. I can't even draw. And strongly what? Heated. Once I see the strong, what do you notice? It is what? Elimination. Type of reaction that occurred. Straight case. Elimination. We're done. Balanced equation. Come, let's see. And we are done. Which compound Q? Where's compound Q again? I don't remember what Q is. Oh, we did Q, right? That's Q. 2-chloro-butane. All right, come. Can you please answer this for me? I want to see what you guys are going to answer. You have 1 minute. 2-chloro-butane. I want you to write the end product. I want you to try. I've been the one doing it all along. Reacting with concentrated sodium what? Hydroxide. And there's what? Strong what? Heat. What are you going to get? 6 marks. Come. Let's try. And that will be the final question for the day. Even if we don't do organic before you write again, guys, I'm covered.
see a thing when I said remove from the ceiling? What? I need a question when they said remove from the ceiling. First question.
Are we done? Are we done? Done? Shamil? Done? Guys at home, are we done? Let's mark 30 seconds. So if we eliminate, what are we removing? We're going to get rid of this Cl, right? The question is, which hydrogen are we removing?
Hydrogen are we removing?
Yeah, we have to remove a hydrogen with this Cl. Can't just remove Cl alone. So which hydrogen are we removing?
The second one on the left.
We're going to get rid of this guy. Do you know why? According to Zaitsev rule. So I have removed this, right? Now I need to remove one hydrogen. It's either going to be this or this. But the poor gets poorer. This guy has 2 hydrogen atoms. This guy has what? 3. So we remove from this one. We punish him for being poor. Make sense? So that is the Zaitsev rule there. Alright, so what are we going to have? 1, 2, 3, 4. 1, 2, 1, 2, 1 third. What do we have? Hydrogen, hydrogen, hydrogen. Now that's going to be a double bond because it's now empty. But now we are not done. We have removed HCl. So I have sodium hydroxide and HCl. Acid and base. What would I have? NaCl plus water. That writes 6 marks. Full structure. So please understand what we remove, what we don't remove, and how we remove. I hope that it makes sense, everybody. Guys, if I don't do organic again till you write, this particular lesson should assist you in dealing with any organic reaction.
So what should you say?
Are we okay, guys? Let me know.
1.1.
Okay, let me shut this off. We're good, right? Okay. Lovely. We have a program for next week. Please follow what I have on the group and then we just work like that. Okay. All right, guys. Have a lovely, lovely evening. And this lesson is available again. I think it's just organic. So please go and rewatch anything organic. Come back to this lesson and we're good.